hello, welcome to Homeschool. This is your class 10 mathematics NCERT or CBSE board. We are in our chapter 15 surface areas and volumes. Your exercise 15.2 fourth problem. A pen stand. Imagine a pen stand made of wood is in the shape of a cuboid. A pen stand is in the shape of a cuboid. Is this a cuboid? Yes. A pen stand is made up of wood is in the shape of cuboid with 4 conical depressions. Conical depressions means, look here, this type cones are digged from this wooden cuboid. Okay, so this is big cone, but we are going to scoop out small cones from this. 1, 2, 3, 4. 4 cones are removed in this wood. Why do we remove these cones? In order to make this wooden cuboid as a pen stand. Look here, imagine this as a pen. This is conical shape you need to imagine. In that conical shape, this pen is kept. Like this, how many pens? 4 pens are kept in the pen stand. 4 pens are placed in the pen stand. Let us read the problem once again. A pen stand made of wood is in the shape of a cuboid. Either this or this you can imagine. With 4 conical depressions. 4 conical depressions to hold pens. The dimensions of the cuboid are 15 centimeters by 10 centimeters by 3.5 centimeters. What are these dimensions? Cuboid is a 3-dimensional figure. What are the 3 dimensions it have? Length, breadth and height. Length 15 centimeters, breadth 10 centimeters, height 3.5 centimeters. These are the dimensions for cuboid. The radius of each of the depression, we are talking about now cone. The radius of each of depression is 0.5 centimeters. What is the radius of this cone? 0.5 centimeters. And the depth is 1.4 centimeters. Depth considered as cone height. Cone height is how much? 1.4 centimeter. Find the volume of wood in the entire stand after removing 4 cones. Let us understand the problem again. There is a wooden cuboid. It is a 3-dimensional figure having length, breadth and height. In this wooden block, 4 conical depressions are done to make this as a pen stand. These 4 depressions, 4 pens are placed in this pen stand. We are not talking about pens. We are going to talk only about the pen stand. Imagine this is a cuboid, length, breadth, height given. Then 4 cones are removed. Remove that 4 cones. Okay, 4 depressions are done. Right? After removing 4 cones from this cuboid, how it looks like? So you just imagine, is this the way like this? Yes. Now what is the remaining wood volume is your problem. How can we find out? In total volume of this cuboid, if you remove volume of 4 cones, you are going to get the volume of remaining solid. Okay. Let's start our solution. Given a pen stand is in the shape of a cuboid with 4 conical depressions. Cuboid, 4 conical depressions. I have written in a given data. The dimensions are, dimensions of what? Cuboid. Dimensions are length, it is represented by L. First one, what it is? 15 centimeters. Next, breadth B is equal to 10 centimeters. Height, length, breadth, height. Height is equal to 3.5 centimeters. And next we talk about the cone measurements, what they have given. The depth Depth means h, height. But here we have cuboid height and cone height. So both are not same. Both heights are not equal. So we need to mark this as h1 and mark this as h2. Depth h2 of each conical depression is 1.4 centimeters. Radius is represented by r of each conical depression is. Radius is how much? 0.5 centimeters. Volume of wood formula. Frame the formula. Volume of cuboid minus, how many cones you can see? 4. So 4 times volume of cone. 4 times volume of cone will give you the volume of wood. Volume of cuboid formula. Length into breadth into height minus 4 times volume of a cone. 1/3 pi r square h. Now substitute the values. Length 15 into breadth 10 into height 3.5. Let us write 35/10. Yes? 3.5, directly I write it as 35/10. Minus 4 into 1/3. Pi value is 22/7. Radius of what? Cone. 0.5. 0.5 into 0.5 into height of the cone 1.4. Okay. Now I don't want all these decimals. Look here carefully, children. If you want, you can change in next step also. Better this one also. Let us write in next step. Okay. Is equal to 15 into 10. 3.5. Convert here. 35/10 minus 4 into 1/3 into 22/7 into 0.5 can be written as 5/10 into 5/10 into 14/10. Okay. This 10 will be cancelled. And here 5 1s, 5 2s. 5 1s, 5 2s, and here 2 7s are, 2 5s are. Now, this 7 and this 7 will be cancelled. 2 11s are 22. That's it. Is there anything here? No. Now look this side. 15 35s are. Let's do the multiplication. 35 15s are, 5 5s are 25, 5 3s are 15, 15 plus 2 17, 35 1s are 35, and it will be 12 5 25 is equal to 525 minus, let us see here, children, what do you have? 11 is left. 11 4s are 44 by 3 2 and here 5. 5 2s are 10, 10 3s are 30. 44 by 30 you have. If you want, you can convert this into decimal. 30 44s are 31s are 30. That will be 14.0. 30 table where you get 140. 33 4s are 120. 35 5s are 150. So let me take here 4. 34s are, it will be 120. 140 minus 20 will be 20. And again, then put 1 0 here. 30 table where you get 200. Just check it out. 8s are, 38s are how much? 240. No. 37s are 210. Then again 36 are 180. So that will be again 20. Then it continues. Let me stop my division there. Is equal to 525 minus 1.46. And now subtract this. 525 minus 1.46. 525 minus 1.46. If you want, you can take point and 2 zeros there. Now 10 minus 6 will be 4, and here 9 you have. 9 minus 4 will be 5, and you have taken one number from here. This will be 4. 4 minus 1 will be 3, 2, 5. Therefore, your answer is 523.54. What is the unit we need to write here? Centimeter cube. This is the volume of wood which is remained after removing 4 conical depressions. What you can write final statement here? Therefore, volume of wood remained in pen stand. Volume of wood remained in pen stand is equal to 523.54 centimeter cube. This is your final statement. Okay, understand the problem carefully. We need to see cuboid and cone here. We are talking about two solids, cuboid and cone. Cuboid dimensions means length, breadth and height given, and whereas for cone, radius and height given. Carefully write the formula, substitute the values, you are going to get the answer. See children, I just remember now, before problem what we have done, cylinder height and cone height. Whereas we discussed in the given part, we have written H1, H2. While I was writing formula, I just used H. Whereas substitution of values, everything is right. You please correct that volume of a cuboid LBH1. And whereas volume of a cone 4 times 1 by 3 pi r square H2. Okay. I hope you people will correct the small H1 and H2 you mark there. Instead of H1, H2, I have written only H. Right? Now, let's start our next problem. That is your problem 5. A vessel is in the form of an inverted cone. We used to see this is a cone. Right? Now we are talking about inverted cone. See, this is the inverted cone, and what they said here, its height is 8 centimeters. Height of the cone is 8 centimeters. From here to here, it is called as height. Height is how much? 8 centimeters. And the radius of its top, look here, this is the radius of its top, which is open, is 5 centimeters. See here, this is your solid cone, but we are talking of a open cone. This is a solid cone, but in this problem, we are discussing about the cone which is hollow, which is open at the top. It is filled with water up to the brim. Up to the brim, up to the top, this cone is filled with water. So as this is a solid cone, I cannot give you a clear idea. To give a clear idea, I am going to take, this is a cylindrical one, right? So take water up to the brim. But you people please imagine it as a cone. What is happening in this problem, I'd like to show you. Okay, please don't consider this as a cylinder. You just see what is happening and you imagine the same inverted cone. Let's read the problem. Filled with water up to the brim. You can say up to the top. This is filled with water. When lead shots, each of which is a sphere of radius 0.5 centimeters. We need to imagine lead shots here. When lead shots, each of which is in the form of sphere of radius 0.5 centimeters. This is not a lead shot, but please imagine it as a lead shot, and each lead shot having a radius 0.5 centimeters are dropped into the vessel. So look here, I have taken some lead shots. I am dropping into the cone where the cone is filled with full water. Now what's happening? Can you see here clearly? Look here carefully. Water comes out. As I throw lead shots in this, what is happening? Water comes out. See here. Water is coming out. Why it is coming out? Can you say? How much water is coming out? See here, volume of the lead shots thrown in this, that much volume of water will be coming out. So still I try to throw some lead shots in this. So look here, water is flowing down. Can you see? See, what is the volume of the lead shots I throw in this? That much amount of volume of water is coming out. Okay, I hope you all people have understood the problem, right? Lead shots and this is water, but this is a cylindrical glass, but you imagine as a inverted cone. Cone also same thing will be happen. If cone is fully filled with water, when lead shots are dropped in this, the volume of lead shots, that volume of water will be coming out. Okay, now you have seen the clear idea of the problem. Now let's see this picture. Inverted cone, radius 5 centimeters, height 8 centimeters, and spears are dropped. Let me draw one spear aside and write the radius of the spear. What is the radius of the spear? 0.5 centimeters are dropped into the vessel. How many lead shots? They did not give us. Read the problem carefully. 1/4 of the water flows out. See here, water is flowing down. How much amount of water is flowing down? 1/4 of the water in the cone is flowed out. Find the number of lead shots dropped in the vessel. So they did not give the number of lead shots. We need to find out how many lead shots are dropped in the cone. So once again understand the problem. Cone is fully filled with water. Lead shot is in the shape of a spear and each having radius 0.5 centimeters is dropped into this cone and the water comes out. How much amount of water came out? 1/4 of the water. Okay, first, how much water there? If we try to find the volume of a cone, that is the volume of water. 1/4 of the water came out. So, we are going to talk only about the water which came outside. 1/4 of the water. How much volume of water came out? By volume of one lead shot. How to complete this problem? The water which came out, how much water? 1/4 of the volume of a cone. 1/4 of volume of cone by volume of one lead shot will give you the number of lead shots thrown in the cone. Okay, let's start our problem. Given height of cone. Height of cone is how much? Let us write this as h. Height of cone is 8 centimeters. Radius of cone. Radius of cone r is equal to 5 centimeters. Next, radius of lead shot. Observe here carefully. We are talking about another solid where that radius is different and this radius is different. Then at that time, you please take here R1 and this is R2. R1, R2. Then cone radius is R1. Spear radius is 0.5 centimeters. Now, frame the formula. Number of lead shots. You need to find number of lead shots, right? Number of lead shots is equal to 1/4 the volume of water by volume of 1 lead shot. Volume of 1 lead shot. 1/4, 1 by 4. Volume of water. Volume of water means what? Volume of cone. Volume of cone formula 1 by 3 pi r square h by volume of 1 lead shot. Lead shot is in which shape? Sphere. Volume of a sphere you need to write. Volume of 1 lead shot. Volume of a sphere is 4 by 3 pi r cube. 4 by 3 pi r cube. Now observe here. Multiply this one. 1 by 4 into 1 by 3 it will be 1 by 12 into pi into r square. R square means what, children? This r we are talking about the cone radius r1 and this is r2. R1 value was 5 centimeters. 5 into height of the cone. Height of the cone is 8 by 4 by 3 into pi. I am not writing pi value because I am going to cancel this pi. Okay, if you have a chance, you can cancel like that. Pi cancelled. And here R2 cube. R2 value is 0.5. So write this as 0.5 into 0.5 into 0.5. Instead of multiplying, better split like this and cancel. Now will it cancel? Yes. 4 3s are 12. 4 2s are 8. Observe here, children. This 3 and this 3 will be cancelled. Okay. Now, this will be equal to 50 by 4 into 0.5 can be written as 5 by 10. 5 by 10 into 5 by 10. Now this one, 5 2s, 5 2s, 5 2s it will be. 2 2s are 4 cancel. So 1 2 is left at the denominator. That means 50 by 1 by 2 is left. So bring these 2 to the numerator. 50, do the reciprocal and multiply. 2 by 50 into 2, it will be equal to 100. So therefore, final answer. What is your final answer? Number of lead shots dropped in the vessel. Therefore, 100 lead shots are dropped in the vessel. Therefore, 100 lead shots are dropped in the vessel. Understand the problem carefully. Imagine the problem. They have asked us 1/4 of the water came out and each sphere radius, cone height given. How many lead shots are thrown in the vessel? So, how many they are thrown, we don't know. But volume of these lead shots, that much volume water came out. Okay, in this cone, 1/4 of the water came out. Volume of cone, right? 1/4 water of volume of cone. That is 1 by 4 volume of a cone by 1 lead shot volume. If you are able to calculate this one, you are going to get the answer 100. That means number of lead shots thrown in a vessel is equal to 100. Let's see sixth problem. A solid iron pole consists of a cylinder of height 220 centimeters. Imagine this is a wooden cylinder, but you please imagine it as a iron pole consists of a cylinder. You can see this cylinder, iron pole consists of a cylinder of height. What is this height? This is 220 centimeters. And base of diameter is diameter 24 centimeters. Then what about the radius? 24 half is 12 centimeter, which is surmounted by another cylinder. This is a cylinder and again another cylinder is surmounted on this cylinder. You people please imagine this is another cylinder. It is surmounted on the cylinder, right? By another cylinder of height 60 centimeters. What is this cylinder height? 60 centimeters. Height of the cylinder is equal to 60 centimeter. Radius is equal to 8 centimeters. See here children, you can see two cylinders. One is having diameter 24 centimeters, means radius will be 12 centimeters. Surmounted by another cylinder having radius 8 centimeters, means this is having small radius and this is having big radius. 12 centimeter radius and another cylinder is placed on this cylinder. This is having a radius 8 centimeter. Find the mass of the pole. Find the mass of the pole. When we are talking, this pole means combination of two cylinders mass we need to calculate. Given that 1 cubic centimeter of iron has approximately 8 grams mass, we need to find mass of this complete iron pole. How can we calculate mass? In the sense, we need to calculate volume of these two cylinders. Volume of this cylinder plus volume of this cylinder. Volume of this cylinder plus volume of this cylinder will give you the volume of pole. Next, you can find out the mass of the iron. Start the solution. Given height of larger cylinder. Height of larger cylinder is how much? Height 220 centimeters. We are talking about two cylinders' heights are different. If they are different, we differentiate with H1, H2. Diameter of larger cylinder. What is the diameter given? Diameter D is equal to 24 centimeters. And radius is nothing but half of the diameter. That will be 24 by 2 is equal to 12 centimeters. And radius R is equal to 24 by 2 is equal to 12 centimeters. Next, we are going to talk about the smaller cylinder. And height of smaller cylinder, both having heights. So, we are going to differentiate this with H1 and this with H2. Height of smaller cylinder is equal to 60 centimeters. Radius, this is having radius and this is also having radius. So, we differentiate with R1, R2. Radius of smaller cylinder is equal to 8 centimeters. Total volume of pole. Now, we are going to frame the formula for this pole. How can we frame? Volume of this cylinder, larger cylinder, plus volume of smaller cylinder. Let's write here. Volume of larger cylinder plus volume of smaller cylinder. That will be, write the formulas. Volume of larger cylinder or smaller cylinder. Cylinder volume is same. Right? What is the volume of a cylinder? Pi r square h. Pi r1 square h1. And next one, pi r2 square h2. In these two, is there anything common? Pi is common. Let us take out pi common. Pi take out common. R1 square H1 plus R2 square H2. They have given pi value. Use pi value 3.14. Let me substitute 3.14 into R1 value. R1 value is 12. R1 square. So multiply 2 times into H1. Where is H1? 220 plus R2. R2 value is 8. 8 into 8 into 60. Substitute these values carefully. Now next one, 3.14 into 3.14 into 12 12s are 144. 144 into 220. We need to do the calculation in rough column. 220 into 144. Multiply. 4 zeros are 0, 4 twos are 8, 8, and this will be 880, and here it will be 220. 0, 8, 11, 3, 1, 6, 8, 0. If you multiply this, 3, 1, 6, 8, 0 plus 8 8s are 64. 64 60s are we need to calculate. Calculate that one also here. 64 into 60. 0 0. 6 4s are 24. 6 6 are 36. 36 plus 2, 38. That will be 3,840. Add for this 3,840. Right? Now add these two. 3,1680 plus 3,840. Add here. 0. 8 plus 4 will be 12. 15. 5. 3. Okay. That will be 35520. And now let's continue the calculation part here. Is equal to 3.14 into, if we add these two, what we got there? 35,520 we got. Now again, we need to multiply these two. Again, we need to do the multiplication. Do the calculation part here. 35520 into 3.14. 4 zeros are 0, 4 twos are 8, 4 fives are 20, 22, 12, 14. And this one, this will be 2, 5, 5, 3. Okay, and multiply with the 3. 3 zeros are 0, 3 twos are 6, 3 fives are 15, 16, 3 threes are 9, 10. Finally, 8, 2, 13, 15. If you multiply, you are going to get an answer, this one. But here, 3.14 decimal there. So, put decimal point after 2 digits here. That will be your final answer here. 111,532.80. You can skip that 0. 0.8. We are talking here about the volume. So, write here centimeter cube. Okay. 111,532.8 centimeter cube is the volume of the pole. Volume of the pole is equal to this one. Now, is the problem completed? No, it's not completed. Still, we need to calculate something. What it is? 1 cubic centimeter of iron has approximately 8 grams mass. Then what about this volume mass? We need to calculate the mass of the pole. Right? Given mass of 1 cubic centimeter is equal to 8 grams. Then what about the mass of this? Mass of 111,532.8 cubic centimeter is equal to, how can we calculate? Multiply this with 8. 32.8 into 8. Now directly you can multiply here. 8 8s are 64, 8 2s are 16, 16 plus 6, 22, 8 3s are 24, 24 plus 2, 26, 8 5s are 40, 40 plus 2, 42, 8 1s are 8, 8 plus 4, 12, 8 1s are 8, 9, 8 1s are 8. And you have a decimal point here. So put decimal point here. That will be 89262.4 you got. This is grams, right? Convert this grams into kilograms. How can we convert this? This you divide with 1000. You divide this one with 1000, then it will be converted into kilograms, kgs. Then what is the change we do here? 3 zeros. Put decimal point after 3 digits from the decimal point, right? That will be 1, 2, 3. Count 892.2624 kilograms kgs of mass. Therefore, mass of iron pole. Therefore, the mass of iron pole is equal to 892.2624 kgs. Understand the problem carefully. There is nothing there to by heart. Understand here, 2 cylinders are placed and this is an iron pole. Therefore, volume of this cylinder plus volume of this cylinder you find out. Then each cubic centimeter is 8 grams of mass. So, find out the volume of the pole and multiply with 8. You are going to get the mass of the pole. Okay, mass of iron pole. Final answer is 892.2624 kilograms. We got answer here grams. That grams convert into kilograms. With this, we are going to end our session today. In our next session, we are going to continue with the problems. Until that, keep watching. Thank you all.